Fuel cells can possibly power anything, from tiny microchips to cars to entire buildings and power plants. Getting the juice they produce is a complex process. Let's break down what they are and how they work from an expert, Professor Tom Fuller from the Georgia Institute of Technology.
A fuel cell is a device that takes stored chemical energy and converts it into electrical energy directly. Essentially takes the chemical energy that's stored within whatever fuel you have. It could be hydrogen, it could be methane, it could be gasoline, and then through two electrochemical reactions it converts that directly into electricity. The major components of the fuel cell are the electrolyte, which is also a separator, so it keeps the reactants from mixing together. The next pieces are the electrodes, and these are catalysts where the electrochemical reactions occur. And then beyond that, there's typically a bipolar plate, or again, sometimes called a separator, but this is a way to collect the current and also build the voltage from the cells. The fuel cell runs best on hydrogen, but hydrogen is not, available. You can't dig up hydrogen out of the ground. You can dig up a fossil fuel and convert it into a hydrogen-rich stream. But to do that in a fuel cell, you need to reform it and then clean up the gases quite a bit before you can put it in a fuel cell. There are certainly fuel cells that have been looked at to take gasoline, reform it in a vehicle, convert it to a hydrogen-rich stream and run a fuel cell, but it's a very complex process, and most people have decided that that's not the right route to go. There are specific challenges that are still present. One is that the volume of the fuel cell, is relatively large compared to the volume of an internal combustion engine. So you've got to fit this into the vehicle, and that's always hard to do. So you've got to really work hard to either get the technology better to make the fuel cell smaller or just package it into the vehicle. So this is a typical device that we use for laboratory testing. It's a single cell, which means it contains one fuel cell, so it generates around 0.8 volts. And if you wanted larger voltages, you have to put them in series. That's the ionomer membrane, that's the electrolyte and the separator, and then this black here is the electrodes, where the electrochemical reactions occur. And then on top of that, you just have basically hardware that holds it all together so you can control these things. And this is a fully assembled version where we provide gases in and out of the cell, and we have electrical connections to take the power out. I think the major drawbacks to fuel cells is their cost compared to competitors. They're providing things you're already getting today, so they have to do it either more efficiently or at a lower cost, and so far they really haven't been able to crack that nut to get to cost that's competitive with other devices.